This is Group F for ET 255, and we will be discussing our site, system, and economic analysis for the implementation of a new renewable energy system. Our client is the Harwell family. Currently, they are living in West End, North Carolina, which is located in Moore County. The family lives on a 0.53-acre property and consists of 3 adults and 2 children. Currently, this is not enough space to house a residential wind energy system, which is what the client is looking to install. Currently, the average annual household energy consumption is 15,893 kilowatt hours. Below are figures of the average annual consumption percentage of each appliance in the household, as well as a breakdown of the electricity usage and corresponding cost per month. If the family decides to relocate, the energy consumption will most likely stay consistent, assuming that the clients will reside in a similarly sized home and have consistent usage of the same appliances. Based on the needs of the Harwells and their desire to install a residential wind energy system, it is suggested that the family relocate to Onslow County, North Carolina. This would be about a 3-hour move for the family to a semi-rural county that is one of the largest in the state and provide ample space for personal land property.
Onslow County has an average wind speed of 23.63 miles per hour, which is well above the typical small wind cut-in speed. The median property value is about $270,000, making this an affordable place for the Harwell family. The average elevation is 11 meters since it is a coastal county, so the ground is flatter with fewer obstructions, perfect for a small wind system. There's a population of about 207,000 people, and the specific stream we chose to use was the New River. The median stream flow rate is 75 feet per second, and the median stream discharge rate is 35 feet per second. The wind speeds in Onslow County are well above the average for North Carolina and the U.S., especially during the summer months. The city of Jacksonville, North Carolina is located along the New River, and its wind data can be used when designing the system. This windrose is important to direct the angle of the wind turbine when installing. The proposed site for the Harwell family includes at least 1.5 acres with a clearing on the land fit to house a small wind system with no obstructions, and a flowing stream with enough flow to power a small microhydro system. The specific residence that we recommend for the Harwell family is at 270 Howard Road, located in Jacksonville, North Carolina. It has 2.96 acres containing the New River and cleared out land for the wind turbine, making it the perfect location for the Harwell family and their energy needs.
Based on the Harwell family's annual energy consumption, we've compiled a wind turbine system that will be able to help this family reach their energy production necessary for them to become net zero on their energy consumption. This system is rated primarily for 1 kilowatt of power. However, it is capable of maxing out its production at 1.5 kilowatts, leading to a voltage amount of 48 to 110 volts. The height and diameter of the turbine's rotors are 2.8 meters, 9.2 feet, and 2 meters, 6.6 feet, respectively. The turbine will have a startup wind speed that requires the wind to reach 3.4 miles per hour to operate, and at proper efficiency, the wind speed will need to reach 22.3 miles per hour. However, if the wind speed reaches up to 111.5 miles per hour, this will put the turbine system in danger. The generator of this system will also be made primarily a permanent magnetic generator that is capable of operating at nearly 96% efficiency. The overall weight of this system will rate around 26 kilograms or 61.6 pounds and will produce noise greater than or equal to 45 decibels when operating. Furthermore, this system is capable of operating in temperatures ranging from negative 20 degrees Celsius to 50 degrees Celsius, with a design lifetime of 20 years, ensuring its operational capabilities for years. With this information, it can be noted that our calculations for this turbine will not be able to meet the Harwell family's energy demands. However, when adding in an additional turbine, the resulting energy production will be 14,895.36 kilowatts. When combining this energy with the energy produced from the micro hydroelectric system, the Harwell family will be able to reach a net zero system that they desire.
So after our proposed wind system, we have a second proposed renewable energy source, which is our microhydro system. So the microhydro system would be able to cover all extra electricity needs that weren't met by the wind system. And the wind system is in a very optimal location with high, consistent wind speeds, but the microhydro wouldn't be in such an ideal location because, as you can see, there's such a low elevation change, only about 7 meters. So there were obstacles to overcome with that, which we'll go over, but it would be an effective system for a good price. So as you can see here, the median flow rate for this system was about 75 cubic feet per second, which going into gallons is about 33,660 gallons per minute, which is a very high flow rate for a river. So we proposed to use about 300 gallons per minute of that into about a 6-inch pipe, so to reduce the amount of friction loss, as we only have about 7 feet of hydraulic head. So with the system losses with smaller pipes, we wouldn't be able to have as efficient of a system. But with the 6-inch diameter pipes, it would be more expensive. But as you can see, we'd only lose 1.2 feet of head. So we would be down to about 5.8 feet of dynamic head. So as you can see in the calculations, this turns out to be per month about 125 kilowatt hours of electricity, and annually about 1,503 kilowatt hours. So a pretty good system. So here we have the proposed battery system for this microhydro. With the wind energy being the main power source, this battery system would help store up a little energy in case the wind energy is down, although it should have its own battery backup. But this would be able to cover about a day's worth. So you can see the calculation, and you can see for a 24-volt system, need about 4 batteries, a little less, but about 4 batteries to reach the amp. So then here we have the different components of this microhydro system. So starting at the intake, we would use an open-ended pipe, as you can see in this picture, with a settling container, because it is so easy to clean and it is very cheap, which are key priorities for this client. This would allow us to reduce the price for this otherwise often expensive thing, and being easy to clean, it would be not very time consuming. Then we have the penstock, which we use HDPE with a 6-inch diameter. So I went over that previously. That would reduce the friction, and HDPE is resistant to all temperatures and conditions, which would be important in this coastal area. And we also have about 200 feet, which would increase the head loss, but it would increase the overall hydraulic head due to us being able to have a larger increase in elevation change. Next, we have the turbine, which we'd recommend an impulse turbine just because of its simplicity and its cost effectiveness. And we also determined that it should use about 4 nozzles to reach that 300 gallons per minute. And you can see the different nozzles we'd use here. And then also in the system, we'd have a dump load, inverter, charge controller, and battery, each fitted for the size of the system, so not too big. And using different sources, we could see that this system cost about $5,840. So nothing too expensive for this amount of energy, and it would be a good system and reliable system throughout the year.
Using the property value in Onslow County for 270 Howard Road in Jacksonville, North Carolina, the family would need to purchase this property for about $289,000. For the wind energy system, we're using a small turbine vertical system that is estimated to produce about 15,000 kilowatt hour annually. And combining all of the wind system components, which we would purchase from the company ALOS, the total cost would be $1,752.33. For the microhydro energy system, we're using a system with an open-ended pipe with maximum efficiency at 7 feet and a median flow rate of 75 feet per second. Combining all the microhydro system components, the total cost would be $5,840. As an overall project cost, the family would need about $296,592.33 for this whole project. But the cost only for the wind and microhydro systems would be about $7,592.33 before adding any incentives. Assuming that the Harlow family takes advantage of the feed-in tariffs for the wind system, they would receive about 3 cents per kilowatt hour, and the price would be reduced to $7,539.76. Also, assuming that the PTC is applied, then the price would be reduced to $7,084.15. However, these costs do not include the installation costs or the maintenance fees. Depending on the companies that the Harwell family chooses to install these systems, they can at least expect to pay an additional $5,000. However, there's still the RPS, the hydroelectric production incentives, and the net metering program that the family can take advantage of. And these incentives amount are determined based on their application needs. For the local incentives for the wind system, there are the Renewable Energy Portfolio Standards, and these are policies that require specific percentages of the electricity produced to be generated from renewable resources. These states are put in place to encourage more renewable energy usage among residential and commercial areas. They also promote economic growth and reduce emissions. For North Carolina, they require 12.5% of electricity to be generated from renewable resources, and they have a cost cap for 1.5% from these systems. There are also feed-in tariffs, which are policies that act like contracts to promote investment in renewable energy sources. They guarantee producers an above market price for any electricity they give back to the grid. These contracts usually last about 15 to 20 years, and the producers are often paid in proportion to their resource and the amount of energy they produce. In North Carolina, these tariffs range from 3 cents per kilowatt hour to 82 cents kilowatt hour. There's also the production tax credit, which allows owners and developers of any wind energy system to claim a federal income tax credit on every kilowatt hour of electricity they sell to an outside party for up to 10 years. For any projects that start construction by December 31st, 2024, the tax credit is estimated to be 2.6 cents kilowatt hour, and there's also a possible 10% increase in this credit for projects that meet other specific manufacturing thresholds. For the local incentives for the microhydro system, there's the hydroelectric production incentives, which are incentives that support hydropower development by providing payments for any electricity generated and sold. The incentives are given to the owners or any authorized operators of the hydroelectric system. The incentives amount are picked based on how much electricity is generated and sold during a specific eligibility window, and no system can receive more than $1 million in an academic year. This program has a budget of $125 million that they can give out to owners. There's also the net metering program, which is a policy that allows customers to generate their own electricity using a renewable energy source, and they can be credited back for any extra electricity they flow back to the grid. There's a system capacity of 1 megawatt, and any systems up to 20 kilowatts for residential systems can be eligible for this program. The utilities credit the customers back based on a rate schedule created by each state. And this credit only applies to the customer's monthly bill, not extra cash.
Overall, it is recommended that the Harwell family move to Onslow County in order to fulfill their renewable energy needs. With the installation of wind and microhydro systems, the family will be able to generate the 15,893 kilowatt hours of electricity they need, as well as an additional 559.72 kilowatt hours of electricity that can be sold back to the grid for profit. We hope that the family takes our recommendation into consideration in order to become completely net zero.